Hello friends, welcome to Susan and John MathTube. In this video, we learn how to solve second order differential equations with method of variation of parameters. Now look at this. This will be very useful if you have a second order linear differential equation with constant coefficient, but the right side will be something not in our standard types. Do you remember we learned equations in the form, or we learned how to solve equations in the form d square by dx square plus p dy by dx plus q times y is equal to r of x. And we had the following rx. We learned how to solve when we had 0 as the right side, and then we learned how to survive with e power ax and some special cases like hyperbolic sign, constant, etc. And then we learned the trigonometric right side sin ax and cos ax, and then we learned polynomials in right side, and then we learned the combinations, exponential into sine, exponential into polynomial, and finally sine into polynomial. So this is exactly what we learned till now. Now in method of variation of parameters, what we do is we will solve the differential equation if the right side is something different than the standard type. Okay, anyway, I'll give you the method. The first thing is form the auxiliary equation, and number 2, solve the auxiliary equation, and you write the CF in the form y is equal to c1 y1 plus c2 y2 plus etc. Anyway, in the problems that they ask in your level, you'll have maximum up to c2 y2. Anyway, if it goes beyond that, you can guess what to do. Okay, and then what we do is we find something called the Wronskian. The Wronskian is a determinant. Okay, I'll denote it by W, and it's nothing but y1 y2 y1 derivative y2 derivative, or y1 dash y2 dash, and this is our y1 and y2. That means y1 is the quantity along with c1 and y2 is the quantity along with c2, and make sure this is not equal to 0. Okay, now we write the general solution, that is y equal to CF we already found here, plus u1 y1 plus u2 y2. This is the general solution. And what do you call this? U1 is actually integral r by w, the right side by w, w is our Wronskian, into y2 dx, and outside don't forget to put negative. And what do you call u2 is integral rx by w, that means right side by w, the right side which we have not seen in the standard types. And standard type I explained in the beginning: exponential, sine, cos, polynomial. Okay, and that will be into y1 dx. I will strongly recommend you copy this much, or you can take a screenshot. I'll put it in a box so that you can save it in your file. Let's learn how to solve problems with the help of method of variation of parameters. So write the first question. I hope you're ready with pen, paper, etc. So please write: solve the differential equation d square y by dx square plus y is equal to sec x. So look at this. Clearly the right side is something different than we have seen before. Okay, so I'll stick to our steps. What is step number 1? Auxiliary equation. Solve the auxiliary equation, write the CF, find y1 and y2. Okay, so I will do up to this. we will write this in capital D. So this is d2y plus y is equal to sec x, that is d2 plus 1 of y, or d square plus 1 of y equal to sec x, and we write m square plus 1 equal to 0. This is the auxiliary equation, and this method is very important for Pokhara University. So m equal to 0 plus or minus I. Okay, you can use the calculator or your brain or anything, but get the answer 0 plus or minus I. And you know what to do. Complementary function is y is equal to e to the power 0x times c1 cos 1x plus c2 sin x. Okay, that is y equal to c1 cos x, because e power 0 is 1, plus c2 sin x. Now look at this. Let's go back to the procedure. I am going step by step. I found the auxiliary equation, I solved the auxiliary equation, I wrote the CF. Now we have to keep quantity along with C1 as Y1 and the other one as Y2. That is why I put it in blue. So we have Y1 equal to cos x and Y2 equal to sin x. Now our job is to find the Wronskian. Wronskian is a determinant. So first you write cos x sin x, and just beneath this cos x you write the derivative of cos x, and here you write the derivative of, okay, whatever is available. So cos square x plus sin square x is equal to 1, and 1 is not equal to 0. Okay, so the condition is Wronskian should be not equal to 0. Okay, now time to write general solution. That is y equal to CF plus u1 y1 plus u2 y2, and I am going to call it equation number 1, where u1 equal to minus right side by Wronskian into y2, and u1 equal to integral right side by w y1. Here the function is in x, so we have to put dx. So the job is almost done. Our job is to find u1 and u2. So let's go for u1. So u1 is minus r. Okay, now comes the right side into action. So the right side is, yeah, sec x, and y1 is cos x, y2 is sin x. Okay, so u1 equal to minus sec x the whole divided by 1 times y2. What is y2? Sin x. Okay, so this is nothing but 1 by cos x into sin x dx, and you know sin by cos is tan x, and integral tan x is log sec x. By the way, I forgot something. Don't do that. Minus, yeah. That's perfect, yeah. Okay, now u2. u2 equal to, yeah, here I can, there is no negative. So right side by w, Wronskian is 1 times y1, that is cos x. Wow, sec x and cos x will get cancelled, integral dx is x. So let's plug in everything into equation 1. So you can write y equal to, CF we already wrote, c1 cos x plus c2 sin x plus u1. What is u1? Yeah, minus log sec x times u1 y1. Where is our y1? Yeah, cos x, plus u2 and y2. Done. That's it. If you want, you can manipulate a little bit, because minus log a is actually log 1 by a, and this can be simplified. It's not compulsory. If you feel like it, do it. You can make it log 1 by sec x, that is log cos x, and outside cos x. So you should put it like this, otherwise you'll feel like combining these things. Never ever do that. Yeah, okay. So I think you understood the method. Now let's do something little bit tougher than this. So this is second question. So please write, solve the differential equation y double dash minus 2y dash plus 2y is equal to e power x into tan x. Now look at this. I told you the standard types are exponential, sine, cos and polynomials. And also exponential into sine, exponential into polynomial, sine cos into polynomial. That's it. That's exactly what we have learned as standard type. So clearly we have not seen this character. We have never seen this character in our standard system. So we go for method of variation of parameters. So step number 1. Now I remember the steps. You are already familiar with the steps. So tell me please, what is step number 1? Exactly, auxiliary equation. But before that, let's put everything into capital D. Let's not forget our pattern. So we get d square minus 2d plus 2 of y is equal to e power x tan x. So first thing, auxiliary equation, m square minus 2m plus 2 equal to 0. Now I'll take my calculator and I'm going to input 1 minus 2 and 2. So we get 1 plus or minus I. So m is equal to 1 plus or minus 1i. I intentionally put that 1. So tell me the CF. CF is y equal to e to the power 1x times cos 1x plus I sin 1x. Now it's important, e to the power x times c1 cos x plus c2 sin x. Now it is important that you take it inside. Look at this. We want it in the form. I'll show you the formula or the standard pattern. See, it should be c1 into something and c2 into something. So it is very, very important. You have to take it inside. So y is equal to c1. Okay, I'll write it with red. So we get e power x cos x plus c2. I'll write with red again, e power x sin x. So till now things are great. So we have to call that first one as y1 and the second one as y2. Okay, now we have to find the Wronskian. So first row e power x cos x and e power x sin x. Ready to differentiate? We have to apply product rule. But I love differentiating functions when I have e power x. I think you remember the trick. There is a small trick. You can keep it in mind. It will give you an advantage when you differentiate e power x into f of x. The answer will be e power x into f plus f dash. Actually, we use this trick to integrate such functions. Anyway, I'm going to write the derivative in a single line. Cos x, if you want, you can apply product rule and take common, but I'm going to do it in a single line. So cos x plus minus sin x, and this will be e power x into sin x plus cos x. It's an awesome trick. Anyway, in determinants, we can take common from each row or each column. Anyway, this is going to come outside. So from the first row, from the second row, and we have cos x sin x, cos x minus sin x, and sin x plus cos x. So this becomes e to the power 2x, because a power m and a power n is a power m plus n, and the determinant will be, you can expand this, so cos x times sin x plus cos x minus sin x times cos x minus sin x, and open the brackets. So we end up with e to the power 2x cos x into sin x plus cos square x minus sin x into cos x plus sin square x. So this will get cancelled and cos square plus sin square is 1, and the exponential function is never 0 because the graph of the exponential function, I explained in many videos, it's the hockey stick. So the graph never touches the x-axis, that means it will never become 0, and at 0 the value is 1 and then it shoots to infinity. So clearly this never becomes 0, so the solution exists. Now our job is to write general solution is y equal to CF plus u1 y1 plus u2 y2, where call it equation number 1, and what's the value of u1? Right side by Wronskian into y2, and don't forget the negative, and the formula for u2 is right side by Wronskian into y1, and the variable is x, so I put dx. Now what we do is let's calculate. So u1 equal to minus, what is the right side? Wait a minute, I'll show you the right side. You might have forgotten the question. E power x tan x. So this is the right side, and this is our y1 and this is our y2. The right side is e to the power x tan x by Wronskian is e power x into e power x. You saw that this is the same as e power 2x. y2, what is y2? Yeah, e power x into sin x dx. So this gets cancelled. This is minus integral sin x by cos x, and again sin x. There are a lot of ways to integrate this, but okay, I can see sin square x here, and I know cos square x plus sin square x is 1. So I'm going to write this as 1 minus cos square x the whole divided by cos x dx, and that will be minus what is a minus b by c? Isn't it a by c minus b by c? That's great. So 1 by cos x, that is sec x cos square x by minus cos x dx. Anyway, you can take this negative inside, or we will do that later. So the first one is minus integral sec x, so log sec x plus tan x. Now this minus and minus will be plus, and integral cos x is sin x. We want this, we'll put a few tick marks with different colors so that we can recognize later. So this is my u1. The next thing, u2. So that will be right side by w. What's the right side? Yeah, e power x tan x by the Wronskian is e power x into e power x times y1. What is my y1? y1 is e power x cos x and dx. So like before, all these things will get cancelled, but the good news is this becomes very simple because cos x got cancelled, and integral sin x is minus cos x. So this is the next thing. Now it's almost time to write the answer. So general solution, you can write general solution is y equal to CF. We wrote that CF. The CF is e power x into cos x plus I sin x. Do you still remember? Long back. Yeah. E power x c1 cos x plus c2 sin x. Now time to write the general solution. So the solution is y is equal to CF plus What is our CF? Do you remember? Yeah, e power x into c1 cos x plus c2 sin x plus u1 into y1, and that will be minus log sec x plus tan x. I think you remember this character, and plus sin x, and into y1. What is y1? y1 is e power x into cos x. Now you can open the bracket, apply distributive property. Okay, plus one more term, u2 into y2. What is the value of u2? We got a very good answer for u2. u2 is minus cos x. I hope I wrote negative earlier. If there is no negative, please correct it. Interval sin x is minus cos x. u2 into y2. What is y2? E power x sin x. Okay. Now let's arrange it a little bit and conclude. So e power x into c1 cos x plus c2 sin x. Now this goes inside. So minus e power x cos x log sec x plus tan x plus e power x sin x cos x minus e power x sin x cos x. So the last two terms get cancelled. This will be the solution. With that, I'm going to wind up this video. So I hope you understood the method of variation of parameters, when to apply and how to apply. I'll be back soon with more videos. So till then, my friends, bye.